Mabot. Welcome to Project Ventive. In our today's video, we are going to talk about the Mabot. Before the video starts, like and share this video. Also subscribe to our YouTube channel Project Ventive for more updates. It is LEGO compatible, easy enough for a first grader to construct with, and fun enough that even nerdy dads like me will become obsessed with it. Bell Robot's Mabot Modular Robot Building Kit is presently the topic of a crowdfunding campaign. Mabot offers a lot of value for the money and is a lot of fun, even though some aspects of it could probably use some refinement. We were given a pre-production Mabot starter kit to review, and while it appears to be mostly done in terms of quality, there are a few components that indicate that it is pre-production. For example, there are no translations into English or any other language for the Chinese lettering that is seen on the boxes and instructions. We have been informed that work is now being done on it. We were provided with PDF versions of the instructions in English that were of high quality and demonstrated what a completed printed version may appear to be like. During our testing, we came across an update that addressed a significant number of instances in which information was lost in translation, and the apps that are used to manage the Mabot are also available in English. The majority of the information that a user would require to understand is presented in the graphical form anyway, therefore the language barrier is relatively low. The Mabot kit itself is a very ingenious design, featuring modular components that can be joined together in a near infinite variety of different ways to construct robots for a wide range of functions. The design of the Mabot kit itself is pretty ingenious. When you consider the fact that Lego pieces may be included in the design of the chassis, the decoration, and other aspects of the vehicle, the amount of conceivable variation increases significantly. Lego adapters. There were also several accessories, such as a set of goggles that could be used to give a robot a face, some slightly opaque plastic pieces that could be used to cover ports and add design aesthetics, and a disassembly tool that could be used to remove the connectors. All of these accessories were included, rods, a cord for charging, and a USB socket that can be used to connect a smart device for programming are both included in this package, as well as 3 color cards for testing color sensitive designs and a straightforward roadmap for evaluating the performance of sensory robots. The several Mabot components can be connected with just a few restrictions, such as each robot needing its control ball and battery ball. However, these restrictions are not insurmountable. The brains of the device are located within the control ball, which also houses Bluetooth and USB connections. The battery ball is what delivers the power for the device. From that point on, all that is required is to use the rods to create connections between the different components, and you can arrange them in whatever configuration you desire. These rods have a dual purpose, connecting the various components of the Mabot both physically and electrically. 2 different Mabot apps are utilized to exercise control over a physical robot after it has been constructed. The Mabot Go app comes with graphical assembly instructions for all of the fundamental robots that have been pre-designed for the kit. These instructions may be found in the app. The user will gain a better understanding of what is possible and how the individual components interact with one another after making a few of these. For instance, the solo wheel is the simplest robot there is. It consists of a control unit located on top, a battery ball, a connection ball with 6 ports, 2 driving balls, and a wheel that is free to spin on its own. The solo wheel is capable of driving about when prone on the floor and then popping upright to drive on 2 wheels while maintaining its balance. From there, other pre-designed robots include a tracker boy to demonstrate how the sensors work, the drag race to demonstrate how the kinetic input touch sensor works, and the explorer to demonstrate how the color and object sensing capabilities of the Mabot system can be used to create a sort of Roomba that does not have a vacuum. Because each of these robots can be assembled in approximately 10 minutes or less, children won't waste time trying to figure out how the various parts go together. However, to build some of the designs that are available in the Mabot Go app, you will need additional components that are not part of the standard Mabot kit. However, after the fundamentals have been mastered, free-range design can be implemented. The primary menu of the Mabot Go app consists of 2 trees. The official building tree, which contains the app's pre-designed robots, and the free operation tree, which has the program options for straightforward remote control of the user's designs. When the Mabot is successfully linked, the controls will immediately appear for every part of the new robot that can be felt. Once the robot's drive units have been calibrated to their proper settings, they will be ready to be controlled. When kids design robots from scratch, one of the things they will learn very quickly is that it is important to consider not only the connections of the components and their placement for movement, but also things like weight distribution, engineering for strength, and so on. This is one of the things that kids will learn very quickly. It's possible that a robot with a hinged arm could look cool, but if the arm is too large about the hinge, the robot probably won't be able to move very quickly or stay linked for very long. Similarly, a pivot joint that has a sensor on top can only sense what it is directed towards. Accordingly, if the pivot is shifted to the side while the robot is going forward, the robot will not see anything in front of it. Observing my 6, 7, and 8-year-old children work something like this out on their own was an educational experience in and of itself. The fundamental set that we were given should be sufficient to meet the requirements of the vast majority of people right off the bat. In the future, add-ons such as the grabber hand and other such features will become useful. It has been brought to our attention that the Kickstarter kits do not appear to have the media kit that we were provided with as a beginner kit to experiment with. The majority of the kits that are featured on Kickstarter only have 2 drive wheels rather than 4, although the most extensive kit does contain significantly more than what we were provided with. It would appear that before beginning the crowdfunding campaign, the Bell Robot team made a few adjustments to the proposed package to accommodate for feedback received. During our performance, we encountered a few problems that are worthy of being mentioned. The first problem was that the control ball stopped working not long after the kit had been turned on for the very first time. This was certainly a manufacturing problem, and considering that these kits were for pre-production, a malfunction was not something that could have been anticipated. The crew at Bell Robot was fast to replace it, and they asked for the previous model to be given back to them so that they could investigate what had caused the issue with the new model. A favorable indicator. The second issue was that one of the Y-joint 3 port connectors developed a crack in it and became inoperable. It turned out that the case was the only thing that was damaged, and it was quickly restored with some super glue. Once more, this is most likely due to a pre-production glitch in the manufacturing process. Other than that, the Mabot has been fantastic. Next, we moved on to the Mabot IDE app after constructing remote control and pre-designed robots with the Mabot Go app. The Mabot IDE software allows users to program their robots from scratch. It's interesting to note that there are multiple forums and conversations on the complexities that may be achieved with this rather straightforward programming approach. The app's programming interface is quite similar to that of Scratch. Therefore, users who are already proficient in creating programs using Scratch will have an edge here. As long as they have a basic understanding of logic, children should have no trouble grasping the concept behind the system, as the majority of the graphical interface is comprised of drag and drop functions. All of the sensors and devices that can be used with the Mabot are already included in the IDE software. All that needs to be done to make use of them is to turn them on in the program that is being written. Therefore, the majority of the time spent programming a bespoke Mabot is spent ensuring that the timing is accurate and gaining a grasp of how to use straightforward if-then trees. Because of the constraints of the Mabot IDE, it is not possible to create bespoke control panels for the remote control of the robot in addition to the programming that is already integrated into the device. This means that even if you can program a robot to do a lot of nice things, you cannot tailor the control panel for the remote control to limit the amount of overriding a user may perform. This is the case even though you can program a robot to do a lot of cool things. Because of this, the remote control will continue to be cumbersome for sophisticated robot designs that contain several moving elements. However, the ability to program if-then statements that take input from the remote control and then add a series of tasks to specific inputs helps to make up for this to some extent. For example, moving an arm joint to the left will automatically activate a torso swivel, which will cause the robot to swing in that direction as well. or by the user twisting the head, which causes the wheels on the robot to spin, so turning the robot as a whole to follow the head. Overall, the straightforward nature of the Bell Robot Mabot's construction makes it an ideal tool for instructing young children on the nuances of imaginative construction that go beyond the straightforward question of what goes where. The Mabot is equipped with a very ingenious system of modular components, and its design is flexible enough to provide a great deal of inventiveness during the process of learning. The activity was a huge hit with my children. How did you like the video? Do you like it? Leave your valuable comments in the comment section below, and don't forget to subscribe to our channel Project Ventive on YouTube.